Hello everyone, this is Brock Skaggs, and I'm going to make this introductory level video on the topic of assemblies inside of SolidWorks. And so what you're seeing before you is a very simple SolidWorks assembly. It's just made up of really three components. We've got these two hinge leaves, if you will, and a pin right here in the middle. And so what we're going to look at today is kind of the bottom-up approach to making assemblies in SolidWorks. And so what we mean by bottom up is basically we'll have assumed that we've already made the individual components in their own separate SLD PRT or files, so own separate part files, and then we're going to bring them together into one assembly file, which will have a file extension of SLD-ASM. And so this will be kind of the finished version. I just want to get you a look at it for now. I've left some degrees of freedom open on this, so you can see I can move this one leaf, whereas this leaf isn't open, and I'll talk about how you can control degrees of freedom inside an assembly. And so with that being said, I'm going to go ahead and close this guy and not save. And let's get started building our assembly. So first, just to kind of look at the parts we have to play with, I've got this hinge leaf part, which we're opening up now. There we go. A little bit of a delay. And so this is kind of one half of it. One thing I have done in this file is implement some configurations here, which is a little bit different. But now basically by toggling through the configurations, I'm able to see different geometries forming here. And so it's a subtle detail that won't really affect us too much inside of the assembly itself. And then I've also got the hinge pin as well. And so notice each of these things are totally separate, right? The pin at this point doesn't know anything about what's inside of the pin, and the hinge leaf doesn't know anything about anything outside of the hinge leaf file there. And so they're two very isolated things. And so now we'll just say, hey, I want to put these things together and create an assembly. So we'll just go File, New. I'll just accept the default tutorial. I'm going to hit escape once to close out of that initial dialog box because I do want to set the units. We're doing with inch systems here, so IPS for the length unit there. Alright, so now I've got a blank canvas, so to speak, to work with. I'm in a assembly template at this point, my initial assembly starting point, and I've got a nice three-dimensional space to work in, just like in the part world. But now I'm going to start bringing in those pieces that I already had. And so to bring in a piece that I've already had, bring in a component, I'll come up here to Insert Components right here from the Assembly tab in the ribbon interface here. So do be careful a little bit here. You notice there's a drop down under the Insert Components button. You can either insert component, you can create a new component or a new part, a new assembly, and you can copy with mates there. For very introductory level and kind of bottom-up approach, you're always going to be going to Insert Components there. The new part and new assembly, that goes to more of a top-down or middle-out approach where you start having assemblies where parts reference other parts from within the context of the assembly and have that drive geometry there. So it's a little more advanced than what we'll see in this video. So I just want to bring in like that hinge leaf as my base part. And so I'll just go straight to Insert Components. Since I already have those components open, because we showed those inside of SolidWorks first, they'll show in that open dialog or open documents area here. If they weren't there, you could go to browse and you could browse your file system to find the parts you're looking for. So I'll go to hinge leaf here. Notice here that says, hey, which configuration do you want? Do you want the 2 or the 3? I'll just go ahead and accept the 2 and hit the green check mark to accept it. So now I've basically brought that part geometry into my working space for the assembly. One kind of technicality note here is basically that's just preserving the link to the where the part file is located. It's not like I'm having to copy and paste all that data inside of the assembly file, but instead it just stores the path to it and is able to show the geometry as needed. So this is my first part that I put in the assembly. One thing to talk about it is that it automatically puts this F next to it as far as fixed. And so I don't really like this personally. I like to relate things back to the frame of reference of the assembly itself. So what I mean by that is this origin and these front, top, and right planes which are associated with the assembly. Because if I pop this open and actually see the details of this part, notice you get the entire feature tree associated with the part, and it has its own front, top, and right origin as well. So you can use these. Sometimes you'll use these datum planes associated with a part to align something in a certain fashion. So don't forget about they're there. But I want to have more control. So I'm going to right click on the part and I'm going to say float. And you'll notice that little F sign goes away, and now it's a minus sign, very similar to a minus sign in terms of the sketching environment when you think of things being underdefined. And so I want to basically place this first part within the frame of reference of the three-dimensional space of the assembly. So to do that, you're going to go to mates. Mates are how you position the parts relative to each other, or position this initial part relative to the context of the overall assembly. So I'll click a mate here. And then one thing that happens right off the bat here is it's saying, hey, I need a mate, and so now I need some information from you. And in this case, I'm just going to set these origins to be coincident there. So I just click the two origins, and I'm going to say, hey, that looks good to me. And so I'll click the green check mark there. Now notice that minus sign went away, and now I just see the hinge leaf there. Also, if I click and kind of drag this, you can see that it says the selected component is fully defined, it cannot be moved. So we're in good shape. Another thing, I can see the sketches associated with this. I'm just going to kind of declutter my screen just a little bit and remove those. All right, so very good. I've inserted a hinge leaf part. That one there stands for the first instance of the hinge leaf, and I've got the two knuckle configuration of it is what that's describing there. So that's all good, but I want to create another instance of that. So again, I can go right up to Insert Components, go to the hinge leaf, and now I can move this second one in here. All right, so if you're familiar with door hinges at all, this isn't going to work, right? I need one with two knuckles and the other with three knuckles. One thing you can do with configuration, this is specific to configurations, you can click the part and I can get this little quick access block here, and I can actually toggle that between the configurations and actually pull up the three configuration state there. So that's good. If I look at the tree structure here, I've got another row in my tree. This node here is referencing the second instance of the hinge leaf. That's why the 2 is there. And then notice it's saying, hey, you're referencing the 3 knuckle variety instead of the 2 knuckle variety. So that's looking good. And now I need to start placing it relative to this first hinge. So first thing, I kind of want to rotate it, and so I try to get it in kind of the close position or approximate position to where it's going to be. And so you can come up here and they've got move components and rotate. Here I don't really need to translate, but I need to rotate, so I'll just click rotate component, and I can click and I can just drag this thing around. And this has a lot of other functionality. You can do like collision detection inside of it. If you have a complex assembly and you want to move something and see if it's colliding with something else, you can always do that inside of SolidWorks as well. But just moving it there kind of gives me a head start from when I start to apply mates. So just the same way we did before, I'll come up to the mate tool. And really the mate tool has quite a few options here, and we'll talk through some of them. I've got kind of categories of mates. I got standard mates, I've got advanced mates, and mechanical. Standard mates are your very basic things. Coincident basic things make things touch, parallel, just like it sounds, make two planar faces, let's say parallel, perpendicular. Okay, everybody understands what that is if they understand parallel probably. Tangent, if I have an arc that's going to become tangent to a planar face, there's that. Concentric, think of two holes that I want to make concentric. Lock is kind of like the fixed variety of the sketch. I don't like to use that one very often. And then here and here are basically distance mates, either in the linear fashion or in the angular fashion here, where I can make two faces that are parallel to each other offset by a certain distance if I wanted to. So those are the standard mates. The advanced mates get into a little more complex. We may demo the width mate here, maybe the limit distance mates. And then we also have the mechanical mates, which were chosen to model mechanical joints, so to speak, like actual hinge joints, gears, screws, those type of things. But since we're just starting off, let's go to the standard mates, and then we don't necessarily have to define our selection first. We can actually click geometry first. And so one way to do this would be to like click these cylindrical faces here. So if I click that cylindrical face and this cylindrical face, notice it's got a preview that's showing up, and it's going to try to make those cylindrical faces concentric. You can see it automatically clicked that mate type. This is actually what I want, right? I want those to be in line, so I'll go ahead and accept that. And so now we've basically constrained a couple degrees of freedom here, right? What I mean by degrees of freedom is originally when I brought this thing into the environment, I could have translated it in any direction, I could have rotated it in any direction, it was very free. But now as I apply mates, I'm going to continue to refine or control the open degrees of freedom of the part. For instance, this guy here on the right has no degrees of freedom, right? I can't move it at all. But this guy on the left still has a couple, right? I can translate it looks like around this axis, looks like the Y direction for the coordinate system of the assembly, but I can also rotate it as well about that axis. You can see I'm kind of rotating it, moving it around a little bit there as well. And so I've got essentially 2 degrees of freedom left. I've got the translation as well as the rotation about that y-axis. So we're looking pretty good. One thing I need to do is fix this problem, right? And so I'll just go to the front view. We can see it a little bit more. Basically, it needs to sit something similar to that right there. And I could achieve this in a few different ways. I'll kind of show a couple here just to talk through different mates. One would be to click, let's say, this face here and this face here. And I could say, hey, let's make them coincident. So that now those are going to lie in the same plane. And if I accepted that, then I think I would have that geometry. Now it would only be able to rotate, as you can see, but it can't actually translate there. That would be one option. I'll delete that and just show a slightly more complex option. And so how do you delete a mate? There's a couple places to look. If you look down here, I'll close it first, you've got this mates node that'll be underneath all your parts, and it's basically going to be a library of all the mates you've applied in the overall assembly itself there. And so at this point, I've applied 3 mates. But the problem is that references all the parts in your assembly. Sometimes it's easier to look in a kind of narrower scope. And so if I know I've got a mate that's attached to this part, I can open up the part, and it should also have a mates folder here. This mates in assembly 2 because of my files assembly 2 there. And I can expose it and see, hey, there's a coincident mate I just applied. Let's say I wanted to remove it. I would just click delete, and there we go. Now this thing should be able to translate as well. And so we showed the coincident mate there just for the sake of the demonstration. Let's go ahead and try a different mate as well. This one I'm going to go a little bit more advanced and go to the advanced mate, and they have something called the width mate. The width mate's nice if you kind of have a tab and slot type scenario there, where you define kind of the bigger opening and then the thing that fits inside of the bigger opening being the tab there. And so in this example, my bigger opening could be defined by the faces of the one knuckle here and here, and then my tab would be the faces of the other knuckle there and there. It's very subtly moved there for the preview, but basically it's going to try to center that tab within the slot that I've defined there. So this should create a very similar type of interaction like that coincident mate before. So that's looking good. And now I've still got that same type of relationship there. So we're doing pretty good. I'm going to leave that at this point, and then I'm going to insert the component, and this time let's go ahead and put the pin in. And so I've got the pin at this point. I just left click for one instance. If I wanted to create multiple instances, I would just keep clicking essentially. And then the pin, as you could probably guess, what do we need to do? We need to put it through that hole, and we need to make that face touch this face here. So for the sake of showing additional mates and ways to make mates, I'll go ahead and expose some temporary axes here. Temporary axes show up when you have holes or cylinders, and they're kind of the axis of the hole or the cylinder. One way I could have done this is click the cylindrical faces and made it concentric, but I could also kind of center this thing within that hole by clicking the 2 axes. And notice as soon as I click those 2 axes, it says, hey, I'm going to make those axes coincident, and I'll accept that. It's just another way to get to the same solution at the end. At this point, if I click it, this thing should still be able to slide in and out, and I want to constrain that. So if you're thinking, hey, I can make a coincident mate, you're on the right track, because I can click that face and rotate the assembly so I can see the underside of that face. Keep those 2 selected, and now it's coincident. So that's looking good, but you'll notice I've actually got 2 degrees of freedom showing up here, right? Or at least 2 parts that have at least 1 degree of freedom showing. It actually is 2 degrees of freedom total here, just because this thing has a rotational degree of freedom and that has a rotational degree of freedom. This one's easy to see, right? You can kind of see the flat moving. This one, it's a little hard to see. If I zoom in, yes, you can kind of see just because that geometry is a little tessellated that it's actually rotating there. So I want to constrain, let's say, the rotation of this one. But you're saying, how am I going to do that? It's got a nice cylindrical face. I don't really have a great flat face that I can say parallel to. And so this is where those planes that we were talking about come in handy. Because one thing I can do is come into the mate tool. And notice I've got the feature tree showing up over here. I can say, hey, I've got the front plane of the assembly. And I can pop this open and I can look at the hinge. And I can say, hey, I've got the front pane of the hinge pin. And I want to say make those parallel there. So here I'm actually applying a mate to the reference geometry planes of the assembly and the hinge pin component there. And that works just as well as a physical face, like a body face, if you will. And so now this one's fully constrained as well. If I try to click and move it, I can't move it. And so what about this last one? Here, okay, maybe you'll leave it open and just want to see it move. Another thing you could do, just since we're talking about mates, is go to the mate tool here. Here I could apply an angle distance mate. And so I can say things like, hey, if I click this face and this face, I want it to be, let's say, 45 degrees of separation. And I just entered a few times to accept that. Now this thing is totally locked down and it's only allowed to be at 45 degrees. Another thing I could do, I'll just go down here and clear out that last mate, is apply a limit distance mate. I think I've got a totally separate YouTube video that shows this, but a limit distance mate would basically say, hey, I want it to go from here, and then I want it to open up only to, say, 135 degrees. And so if you want to do something like that, SolidWorks also supports that. You have to go out of standard mates and into advanced mate. I can go down here to limit distance. It's the same references as far as geometry. I've got to click those two faces. But now I've got to say, hey, what's the maximum value and the minimum? And so I can say, well, the minimum will be 0 when they're touching, and the max will be, let's try 135 there. So I'll accept that. Now notice I've kind of fully constrained all of the parts. I don't see a minus sign there anymore, but this thing will also now be able to move a little bit. And notice I can't move it past that where it's touching, that would be 0 degrees, and I can't move it past the other threshold, which is 135 degrees there as well. Okay, and so we've basically exhausted everything I wanted to talk about in this assembly video, a very introductory level. Hopefully you're getting the idea of, hey, I've got an assembly, it's kind of this three-dimensional environment. I can take the part files that I've already made and pull them into the assembly, start referencing them to each other. That part is done with the mates tool right up here. They use that quite often, and there's a bunch of different mates you saw underneath that. And that's how I can control their location and also can control some of the functionality like we're showing here with this limit distance mate and the fact that I can only move that second hinge through a certain angular space, if you will. Alright, so as always, thanks for watching the video, and hopefully this will help you in building your own assemblies in SolidWorks.